My name is Rob Mamone. I'm the Energy Chain Product Specialist for igus Inc. North America. Today we're going to be talking about gliding applications and a few best practices for designing a system. In previous videos, we've talked about unsupported applications where the upper run, which is this portion right here, will continue moving down. But eventually, the upper run will become either too long or too heavy or both, where the chain potentially could begin to sag. And this is generally where we'll begin to look at possibly gliding an application. And so how do we begin to glide an application? First thing is we have to look at the chain series. Generally, we're looking at anything from an E2 Mini up to an E4-1 and a few other series beyond that for gliding applications. And when we look at them, we've got to look at the design of the energy chains as well. When we're doing unsupported applications, the mounting height begins generally around this portion right here. But when we're gliding it, we want to get the chain to push down on itself quicker. So we will lower the mounting height to somewhere right around here. And when we begin to lower the mounting height, you can see the curve begin to push back. I'll show you that again as it's loaded up here. As I begin to bring it down, it pushes the curve back, which indicates that we will need a longer chain to complete the curve for a lower mounting height application. And it's what igus calls the K2 value versus the K value in an unsupported span. The reason why we can glide our chains in applications is because the design in the side links of our energy chain. This is what we call the glide shoes. This is the surface right here that our energy chains will be gliding on. It's not the crossbars that it might look like. As I got an example right here, as I push it back and forth, back and forth. The crossbars are actually sunken in about 2 millimeters lower than the side plates. This is where a lot of the strength of our energy chains are built into the side plates, and so this is where the applications will glide on. So from our E2 all the way to our E4-1, they all have these glide shoes built into them, and you will see them in various sizes within energy chains. So as you can see in a little sample piece right here, you can look, there's a little bit smaller glide shoes in this versus something along the lines of this. But remember, it's about the right chain for your application. So we will take into consideration all the environment, cable package, speeds, acceleration, all the data that your application will provide, and find the right chain for your application. Next, I want to talk about camber. And we've talked about this in our previous videos, but this is the pre-tension that is molded into our energy chains. I have a couple of chains right here that I'd like to show you what our camber does. The camber helps with unsupported travels, but for long travel, we would like to remove the camber. And I have two chains here, one with camber and one without. And as you can see here from the one with camber, as I push, the back end will bow up. And that's what our camber does. It will create a bow in the chain. Versus the one that does not. As you can see, I push, and there's a tiny bit of camber still remain in there. But in our E4-1 chains, what we do is we take these common plates and we just flip them around. And this will remove the camber from our energy chains. And by doing that, our chains will begin to lie flat within our trough. And an example is here. We would want to make sure this can lie as flat, this piece of the chain would lie as flat as it can within the trough. We just wouldn't want the bottom run to be bowing up. It'll decrease some of the longevity of our energy chains. Lastly, I'd like to talk about the chain fix or strain relief that we may use for our energy chains. We generally talk about chain fix clamps and we talk about tie wrap plates when we're designing an energy chain. When it comes to long travel, general best practices will use chain fix clamps. But something that we have to take into consideration is the height of the chain fix clamp. We want to make sure on the fixed end, it is not taller than the link height. And the reason why, as the chain cycles through when it's gliding, back and forth, if the chain fix clamp is above the link height, it runs the chance of getting hit by one of the crossbars and potentially damaging the energy chain. And again, as I said, we want to make sure this lasts as long as your application. So we want to make sure when we're designing it, we take that into consideration. And here's an example of one that's above and one that is below. If we find ourselves in a situation where there is one above, we probably want to look into something like this where there's tie wrap plates. And what we would do is take one cable per tooth at the end of this with 2 tie wraps and tie the cable down on each tooth that's coming out. Thanks for watching this video. If you have any further questions regarding what we discussed, please reach out to me, and stay tuned for the next video. Thanks again.